force and friction. In last class, we were discussing about simple machines. There are 6 kinds of simple machines. They are lever, inclined plane, wedge, screw, pulley, wheel and axle. We will be learning about the 6 kinds of simple machines in this chapter, and today we are going to discuss about the first one, that is lever. So what do you mean by lever? That is what we are going to learn. Lever is a rod. It is a rod which can be rotated at any fixed point. So it can be rotated at this point or this point or this point or any point in between the two ends, or it can be two ends also. And this fixed point at which it can be rotated, it is known as fulcrum. It will be represented using capital letter F. So lever is a simple rod which can be rotated at any fixed point, and the fixed point at which this lever can be rotated is known as fulcrum. For example, if I am considering this point, and if this lever can be rotated at this fixed point, the name of this fixed point will be represented as F, which means it is fulcrum. Now, what is the use of this simple machines? We know lever is a kind of simple machine, and we are using this lever or any kind of simple machines to make our work easier. So to make our work easier, if we are using lever, we have to apply some force. So the force which we are applying to one side of the lever, it is known as effort. So the force which is applied to this lever, it is known as effort. And for what purpose we are applying some force? We will be applying some force for moving an object or for lifting an object. And the end which we are using for moving an object or lifting an object, it will be represented by letter L, and this L represents load. Load. So a lever, it will be having 3 fixed points. One is fulcrum, then effort and load. It is not mandatory that these points should be at the same positions. It can be changed. So based on this position of this effort, fulcrum and load, the lever can be classified into 3. They are class 1 lever, class 2 lever, then class 3 lever. So based on the position of this effort, fulcrum and load, lever can be classified into 3: class 1 lever, class 2 lever and class 3 lever. So let's see what are they. In the case of class 1 lever, fulcrum will be at the center position and effort and load will be at both ends. This effort can be at this end. This load can also be at this end. But now for time being, I have marked effort at this end and load at this end. And next one is class 2 lever. In the case of class 2 lever, load will be at the center, fulcrum will be at one end, and effort will be at the other end. So what will be class 3 level? What will be coming at the center position? Obviously, effort will be coming at the center position, fulcrum at one end and load at other end. So we know that lever is a rod which can be rotated at any fixed point. So that fixed point is known as fulcrum. So here at this fixed point, this lever can be rotated. In the case of class 2 lever, fulcrum is here. So at this fixed point, it can be rotated. And here, in the case of class 3 lever, fulcrum is here. Again, it can be rotated at this fixed point. If we are writing this fulcrum at this side also, it is correct. Got it? Now, the distance between this effort and fulcrum, it is known as effort arm. So my EA represents effort arm. Then the distance between this fulcrum and load, it represents load arm. So this is the load arm. Distance between effort and fulcrum is effort arm, and distance between load and fulcrum is load arm. So let's say in the case of class 2 lever, we know that distance between effort and fulcrum is effort arm. So this is the effort arm in the case of class 2 lever. And what is our load arm? Yeah, it is the distance between fulcrum and load. So this is our load arm in the case of class 2 lever. In the case of class 1 lever, the distance of this effort arm and the length of this effort arm and load arm are equal. But in the case of class 2 lever, we can see that the length of effort arm is greater than the length of load arm. Correct? Then in the case of class 3 lever, where is effort? Here is effort and here is fulcrum. So this is our effort arm, and distance between fulcrum and load, this is load arm, and in this case load arm is greater than effort arm. I hope you are clear with all these terms: fulcrum, effort, load, effort arm, load arm. It's very simple and easy to define. So fulcrum is the point at which this lever can be rotated. Effort is the point at which we are applying the force, and the load is the point of a lever which is used to move an object or to lift an object. Effort arm is the distance between effort and fulcrum, and load arm is the distance between load and fulcrum. That's all. Then we know that mechanical advantage, we have learned in the last class, mechanical advantage is equal to load divided by effort. Just keep in mind, this principle of lever is that, there is no space, so I am writing here, principle of lever is load into load arm is equal to effort into effort arm. Here L represents load, LA represents load arm, E represents effort, and EA represents effort arm. So this is the principle of what? Lever. So we can say that the product of load and load arm is equal to the product of effort and effort arm. And we already know that this load by effort is mechanical advantage. So let us bring this load and effort to one side of the equal to, and let us make this effort arm and load arm at the other side of equation. So I am going to rub this part, or you won't be getting any space to explain. So let us make some rearrangement in this equation. So already this load is here. And when this effort is coming to this part of equal to, since it is multiplication here, when the multiplication is coming to the other part of equation, it will become division. So we will get load by effort is equal to, already effort term is here, so we will write it here. Then this load arm, when it's coming to the other side of equal to, it will become division, that is load arm. Thus, by rearranging, we got another equation, that is load by effort is same as or is equal to effort arm divided by load arm. And we already know that this load by effort is what? Mechanical advantage. So now for mechanical advantage, we got two equations, that is mechanical advantage is equal to load by effort, and mechanical advantage is also equal to effort arm divided by load arm. Now look at the cases of class 1 level, class 2 level and class 3 level. In the case of class 3 level, here we don't know how much is load and how much is effort, but by saying, we can assume the length of this effort arm and load arm in all these cases. Here in this case, effort arm is equal to load arm. Is it? So let us put some let us put some numbers. So here, mechanical advantage, we know that is equal to effort arm divided by load arm. And we know that this effort arm and load arm are equal in the case of class 1 level. So if effort arm is equal to 5, then load arm is equal to 5. So 5 by 5 is equal to 1. So in the case of class level 1, always this mechanical advantage will be always equal to 1. Got it? Now in the case of class 2 level, again we are applying the formula. Rub all these things. That is mechanical advantage is equal to, again we know the formula, effort arm divided by load arm, and here effort arm is more and load arm is less. So that what will happen, once the denominator is decreasing, then the answer will be increasing. If denominator increases, answer decreases. For example, here let us consider effort arm as 10 and load arm as 5. So how much is mechanical advantage? It is equal to 10 by 5, that is equal to 2. Right? So as a mechanical advantage increases means, then the load arm will be decreasing. If load arm is decreased, then mechanical advantage will be more. They are inversely proportional. Now let us discuss the case of class 3 level. In the case of class 3 level, we know load arm is greater than effort arm. Let us apply the formula. Mechanical advantage is equal to, same thing, effort arm by load arm. We can use the formula load by effort. Why here we are not using, that means we don't know how much is the value. But just by seeing, we can assume the length. We can assume here the length of this load arm is greater than effort arm. So we are just taking some random numbers. But in the case of load and effort, we don't have any idea how much is the force we have to apply. That is why here we are taking this formula, effort arm divided by load arm, for finding the mechanical advantage of class 1, 2, 3 levels. So in the case of mechanical advantage here, we know that load arm is greater. So obviously mechanical advantage will be less. So here, if you are considering this effort arm is equal to 5, it is very less. But load arm is greater. So we are getting 5 by 10. And 5 by 10 is equal to 1 by 2. That is equal to 0.5. So here we can see that since the load arm is greater, the mechanical advantage is reduced to 0.5. Here effort arm is greater and load arm is less. So we got more mechanical advantage, that is 2. And here, since this effort arm and load arm are equal, the mechanical advantage is equal to 1 in this case. So we will get the 3 conditions. What? If effort arm is greater, then the mechanical advantage will be more, and if effort arm is lesser, then mechanical advantage will be less. In the case of class 3 level, or we can say if load arm is greater, then the mechanical advantage is less. And if both are equal, then mechanical advantage is equal to 1. That is what we are getting in this case of 3 levels. Now, can you find out some examples for this class 1, 2 and 3 levels? I hope that you maybe know about seesaw. In the case of seesaw, they'll give something in the center and one person can sit here. I'm not that good at drawing, but you can just see here. And other person will be sitting here. So A is sitting here, B is sitting here. And when A is going down, the B will be going up. And when B is coming down, A will be going up. It's based on this point, is it? So in the case of seesaw, this is the fulcrum. And so when B is going up means here A is applying some force. So A is the effort, and when B is going, this the object is moving up. So that is known as the load. So it belongs to, this is a seesaw, it belongs to which class level? Yes, since fulcrum is a center, it belongs to class 1 level. Same like thing we can see in the case of scissors. In the case of scissors, what is there? So I'm going to rub it. So this is seesaw, next one scissors. I'm just drawing roughly. This is my scissors, which is used to cut. I hope you can just understand the scissors. So this is the place that we are keeping the paper. We are used to cut it. So this part will be the load, and it's a place which we are applying some force. So this is the effort. And since there is a screw here, this scissor is able to move. So this is known as fulcrum. Again, since the fulcrum is coming at the center, this scissor belongs to class 1 level. Hope it is clear for you. Next one. Maybe you might have seen a vehicle which is like this, which is used to take some bricks or for carrying any objects. We will be pushing this vehicle like this, or for carrying waste or for carrying any bricks or something. This is the wheel of that vehicle. And this is the handle, and this is the place which we will be filling the waste or some bricks or something. So this is the point at which this vehicle is moving. So this is the fulcrum. And this is the place at which we are keeping some objects. So this is the load. And this is where we are pushing the object. So this is the place where we are applying the force. So this is known as effort. So this vehicle belongs to which one? Which level? It belongs to class 2 level. Why? Because the load is coming at the center. And so this is the example. Next one is that we know about ice stones. The ice stones, the one which we are using to hold, how to come. If you want to press anything, I'm not good at drawing, so it will be coming like this, something. So if you want to take some ice cube or anything, it will be in between this one, right? So we will be applying force at this part. So this is the part we will be applying effort. And this is the press this lemon or ice cube we will be taking through this edge. So this is known as load, and it's the point at which help us to move this thing. This is known as fulcrum. Since effort is coming at the center, this ice stones belongs to class 3 level. So we can find more examples based on it. So that's about lever. So we are going to wind up this pre-session. You can just have a look at this class, and if you have any doubt, you can feel free to ask. Thank you.